Hello everyone. In this video, I'll be giving an introduction to some of the basic concepts in thermodynamics. And I will also be discussing the Zeroth Law of Thermodynamics. So first we can see what we mean by thermodynamics. Introduction. Thermodynamics is the branch of physics that deals with the concepts of heat and temperature and the interconversion of heat and other forms of energy. So in this branch comes all the theories which are used in developing automobile engines, steam engines, refrigerators, etc. It is a macroscopic science. That is, it deals with the bulk systems and does not go into the molecular constitution of matter. Mainly macroscopic quantities of a system like pressure, volume, temperature, etc. are taken into account while studying thermodynamics. Now we can see the difference between mechanics and thermodynamics. Mechanics deals with the motion of bodies under the action of forces and torques, while thermodynamics is concerned with the internal macroscopic state of the body. That is, internal macroscopic state of the body means the temperature, the pressure, the volume of the body. Now we shall see thermal equilibrium. The state of a system is an equilibrium state if the macroscopic variables that characterize the system do not change in time. That is, if the macroscopic variables which are pressure, volume, temperature remains constant, then we can say that this system is in equilibrium. Now we shall see the definition for a system. What is meant by system? System is defined as any part of the universe enclosed by some boundary through which exchange of heat or energy takes place, and surroundings include any part of the universe which is not a system. Now the surroundings and nature of world that separates the system from surroundings determines whether a system is in a state of equilibrium. There are closed systems, open systems, and isolated systems. In case of open system, exchange of matter and energy takes place. While in the case of closed system, only exchange of energy takes place. And then there is the isolated system in which there is no exchange of energy or matter. Now, we shall see the case if two systems are separated by an adiabatic bond. The two systems are found to be in equilibrium for any values of pressure and volume. That is, the pressure, volume and temperature of the systems remain constant in spite of the values of pressure, volume in the adjacent system. Here, the pressure and volume of the system A, PA, VA will remain the same even when the values of pressure and volume of the system B is PB and VB. Example of such a system is an isolated system. An adiabatic wall is a wall which does not allow the passage of heat energy. Examples include thermoflask, Now, if a diathermic wall is used to separate the two systems, then the values of pressure and volume change on both sides till equilibrium is attained. Example of such a case is when we keep hot tea at atmospheric temperature and pressure. After some time, the tea gets cold as the temperature is exchanged with its surroundings. And the tea attains equilibrium when its temperature becomes equal to the temperature of its surroundings. Now we shall see the zeroth law of thermodynamics. Why is it called the zeroth law of thermodynamics? It is because R.H. Fowler, who formulated this law in 1931, long after the first and second laws of thermodynamics were stated, and so it is so numbered. The zeroth law of thermodynamics states that if two systems in thermal equilibrium with a third system separately are in thermal equilibrium with each other, we can consider two systems A and B and a third system C. A is in thermal equilibrium with C, and similarly B is also in thermal equilibrium with C. Then according to zeroth law of thermodynamics, it means that the system A and system B will also be in thermal equilibrium. And this thermodynamic variable, whose value is equal for two systems in thermal equilibrium, is called the temperature. The zeroth law of thermodynamics gives a definition for the temperature. When the temperature becomes equal, then the flow of heat stops. That is, no energy transfer takes place. And that is when thermal equilibrium is attained. So this is the end of this video. If you have got any doubt in any of the concepts discussed in this video, please comment in the section below this video. Thank you.